In the previous video, I promised to talk more about the Mini VNA Tiny and this Nano VNA, which I've had for a few months, but I don't think I've ever reviewed it. I'm not going to try to review it here, but one of the reasons that I'm talking about this is one of the viewers asked if this was still available for, he said, I think the cheapest price he could find was about $480. And I think on Amazon this morning it costs $488. This is the Mini VNA Tiny Plus. You can also get it on Alibaba. At least I saw a listing for $440. Sometimes that takes a lot longer. I've had stuff from Alibaba arrive in a few days. I've had some stuff not arrive for months. So if you're interested, you might want to go with Alibaba and save yourself essentially $50, $48, something like that. But what I really want to talk about is this Nano VNA. And there's a lot of YouTube videos on this, and I'm not going to try to compete with those. They do a better job than I probably could do. What I did want to talk about was things you might want to think about in deciding whether you want to get something like this or something like this. Now, I paid $40, $39.95 on Amazon for this a few months ago. I think they're now up in the $50 or $55. I don't. This isn't the shopper's channel for electronics, but it's around maybe $50 or a little more. Once again, you can get it cheaper if you buy it from China, but you may have to wait a while. Each of these come with these calibration connectors or calibration units, and they work. They are SMA. The connector types on this. This one's covered up with a little rubber boot, but they're like this. This is an SMA connector. You notice that on this end there is a receptacle for a pin, and then on the corresponding end there is a pin in the center. And one of the things that people don't emphasize enough, I think, is the importance of not twisting that pin inside the here, for example, is a T, and when you put these together, you should only turn this part of the connector as you're putting it together. Don't turn, well, don't drop it either. Don't turn this part. Don't turn it like this, because when you're doing that, what you're doing is you're basically boring out the hole. And these connectors are intended to work at very high frequencies, into the tens or so of gigahertz. So, and for that purpose, they have to maintain their mechanical integrity in order to maintain their electrical integrity, and not tightening them correctly. You really should, especially with the better quality connectors, you should use a torque wrench. So let me talk a little bit about that before I shift to the Nano VNA. Here is a chart that I have marked up that shows the connectors, and I have entered at the very bottom here the PL259, which is the kind of the favorite HF ham connector for amateur radio operators, which I am also one of those. The PL259 only goes out to about 300 megahertz, which is this red line here. I've put a red line there at approximately where Bnc connectors, well, actually Bnc connectors go about to 4 gigahertz. But notice this is in gigahertz. So PL259s are really only useful up to the lower parts of the VHF band. about 300 megahertz. Then you can go higher if you go with Bnc connectors, and of course a Bnc connector is something that looks like this. And once again, let me move the light a little bit so maybe it's a little easier to see. These will generally go up, good ones at any rate, to about 4 gigahertz or so. But when you go above 4 gigahertz, you really have to go with one of these connectors up in this range. And notice that the SMA, which is the kind that I was talking about here, goes out to about 18 gigahertz. Now, that's for a good SMA. The truth is, many of the SMAs that you buy these days, particularly the cheaper ones, they'll only go out to about 10 or 12 gigahertz, but they're still quite a bit better than BNCs and way better than PL259s. But to get that kind of performance, you have to first buy good quality, and second, you have to take care of it. Now, why did I go into all that long rabbit hole? Well, because these units come with these calibration standards that you use to calibrate them. But you need to be careful. This unit goes up to 3 gigahertz. This unit goes up to 900 megahertz. And I would suggest, if you don't need the higher frequency range of this unit, that you go with the Nano Vna. It's like 1/10 the price, or maybe a little more than 1/10 the price, but still it's very cheap compared to this. This is still very cheap. I remember I used to be the director of a research facility that fortunately was partly owned by Hewlett-Packard, later Agilent, later I don't remember all the changes, but for that reason, we had access to some of the best HP and other manufacturers' equipment. So, but even then, it was very unusual for us to go above 25 gigahertz. But today, it's not uncommon for you to have test equipment that will go out to 60 or 65 gigahertz. And that is a special area. Frankly, when you get above a gigahertz, you're half plumber and half engineer. But so why is that relevant to these? Well, these reference standards, I can tell you from having checked them, they will go out to 3 gigahertz. These reference standards that come with the Nano Vna also will go out beyond the Nano Vna of a gigahertz. So these are perfectly adequate standards to use to calibrate the Nano Vna and the Mini Vna. But the reason I think it's important to talk about this before you make a buying decision is, if you're interested, and here is another, I like to make charts. This is a PL259. This is a gigahertz, 2 gigahertz, and so on. The Nano Vna only goes out to 900 megahertz, which is a little under a gigahertz. The Mini Vna Tiny goes out to 3 gigahertz. Bnc connectors go out to 4 gigahertz. But my point is that since both the Nano and the Mini use SMA connectors, you need to be careful to preserve the integrity of the standards, especially of things like the Mini Vna Tiny. Now, I have checked these standards against the Mini Vna and the Mini Vna standards against the Nano Vna, and quite frankly, the standards that come with the Nano Vna, at least the one I bought, are pretty good. They actually go out to, they're not quite as good as these at the very end of the range, particularly for the 50 ohm. By the way, one of these is a short, one of these is an open, and the third one is a 50 ohm terminator. You need all three, as well as an interconnect cable to fully calibrate. You calibrate one of the connectors to what's called S11, or return loss, or there's the SWR, etc. In other words, it's like when you're operating an antenna. But if you're going to be calibrating the other port, you need something to connect between the two, like this SMA cable. Now, this SMA cable is a little bit better than the one that came with this Mini VNA Tiny, which was this one. It came with two of these. Partly, this one is pretty hard to connect between the two because it's not as flexible. But they do work. The Nano VNA only comes with the standards. It doesn't come with any interconnect. So you will need to buy an SMA, at least one SMA cable, and you probably should buy two. And by the way, they usually come with the same connector on both ends as this one does. What you have here is actually an add-on, an adapter. Looks like that allows you to turn a male to a female and vice versa. But what I would recommend is that you buy at least one of these. This is a male to female normal SMA connector. I say normal because there is reverse SMA as well, where the pin is on the this end instead of on the in other words, the pin is in the barrel, not in the ferrule. But if you buy the normal stuff where the pin is in the ferrule and this end is a receptacle for the pin, then I suggest you buy one of these, at least one, so that when you're putting these standards on, as you can see, there is no way to avoid twisting the pin when you're doing this. But the advantage of these is, and especially if you buy one for your 50 ohm, is once you've got it on there, then from then on you're only twisting this part. And that can make a big difference in the high frequencies. And by high frequencies, I'm talking about up in the gigahertz, above a gigahertz. Okay, so that gives me the background to then say, if you need or want to test things in the 1 to 3 gigahertz range, then go ahead and get the Mini VNA Tiny. But if you don't, if all you're doing is working on things below a gigahertz or 900 megahertz, then you can save yourself a lot of money by buying the Nano VNA instead. Now, what will that give you? Well, here is an example. This is a gigahertz out here and 900 megahertz. 900 megahertz is in the middle of the old cell phone band. Now, of course, there's lots of stuff much further out than that, but it covers the entire VHF TV band as well as the low-end UHF range. And now I've expanded this out down here to show you, if you're a ham radio operator, chances are you're only interested in stuff from around 50 kilohertz up to around 30 megahertz. So the Nano VNA is perfectly adequate for that, and it also gives you VHF capability out here well beyond the FM broadcast band and throughout the VHF TV band. So I suggest that if you would rather not pay the $480 or so that this costs, you look for a Nano VNA. The last thing I will talk about are these standards. Now, these came with the Nano VNA. These came with the Mini VNA. I have since purchased some additional 50 ohm terminators, and you may notice that these look a lot like these, which I bought several of. Let me show you over there. They're right here. I bought a pack of 5 of those for like $7. Now, when you get something that cheap, you know you're not getting any kind of quality. But here's the important point. You may notice, I don't know if it shows up on the camera, I've put an X on the top of this one. These are crap. You'll be lucky to get anything out to 30 megahertz flat on those. These, on the other hand, will go out to 150 to 300 megahertz, so they're at least useful through the VHF band. But this one and this one go out to near 3 gigahertz. So be careful the quality of the reference standards you use. If you buy a Nano VNA and it does not come with a set of references, make sure that the reference set you're buying will actually go out to at least 900 megahertz. Now what I'm going to do is show you a little bit of this Nano VNA and how that works, and then the software at any rate for that, and then I'll try to close out this video. Now I've connected the Nano VNA through this cable to my Windows 7 computer down there, and I have loaded up some software, and I'll move the camera here in a second and get it so you can see this a little better. But basically what I am doing is I am sweeping over the full range of the Nano VNA the 50 ohm standard that came with the Mini VNA Tiny. Let me say that again. The expensive, slightly more expensive Mini VNA Tiny came with a set of reference standards, one of which was a 50 ohm termination. That's what I'm sweeping, not the one that came with the Nano VNA. I'll show you that one in a second. Okay, this is a program called Nano Vna Saver. This is version 0.2.1, and I won't describe this because there's a help file that comes with this. There's several software programs that work with the Nano VNA. This is one that I have found useful for what I do. What I am doing is I am sweeping from 1 megahertz to 875 megahertz, near the upper end of the Nano VNA's capability. And what it is displaying here, you may or may not be able to see it. This is an SWR of 1.33, and what I'm sweeping is that reference. So it should be flat, 50 ohms all the way across. In other words, an SWR of 1 all the way across. It's not. It may be hard to read, but there are a few little wiggles. I have a marker set at the midpoint around 500 megahertz, but take my word for it if you can't see it on the video, that it's essentially flat well out beyond the range of this Nano VNA. Now remember, this is the standard that came with the Mini VNA, not the Nano. Now what I'm going to do, oh, by the way, you can see up here, frequency is 499.1, the impedance is 50.86 plus J 0.569 ohms. So essentially 50 ohm impedance over the entire range of the Mini, or of the Nano VNA. And now the sweep, exactly the same as before. The only difference is I've changed to the 50 ohm standard that came with the Nano VNA, and you'll notice that once again 499. The impedance is a little bit higher, 50.11 minus J 0.291 ohms, but still close enough for government work. And you may notice that it's flat. If you can see this, but take my word for it, it is relatively flat, certainly very usable across the entire range of the Nano VNA. This is the standard that came with the Nano VNA. So, what's the whole point of this? If you're going, whether you're going to buy the Mini VNA Tiny or the Nano VNA, I recommend that you only consider units that you can buy with a set of reference standards that are packaged with the unit by the manufacturer. the reason is they will make sure that they're not buying that crap that I showed you earlier, that they're actually using a standard that will work. Now, frankly, for $39, which is what I paid for this Nano VNA, truthfully, a good set of reference standards, an HP lab quality reference standard set would probably cost, I don't know today, but more than $1,000. So you can't be too picky, but I think that the reference standard that came with the Nano VNA and also the one that came with the Mini VNA, they are a real value. And in either case, instead of paying the hundreds of thousands of dollars that you had to pay for vector network analyzers that could go out into the many gigahertz range, frankly, before I retired, today, thanks to a combination of factors, you can get a very nice vector network analyzer that works all the way out to 900 megahertz, nearly a gigahertz, with a set of reference standards. The software you can download for free. I paid just a little over $40 by the time I paid tax on Amazon. Can't guarantee you can get it for that price, but you can get it for close. $50, $55 maybe. So, I hope this will help those of you that have been wondering, should I buy the Mini VNA Tiny? Well, if you need a frequency range above 900 megahertz, I would say yes, go ahead with the Mini VNA Tiny. But if you are working below 900 megahertz, like most amateur radio operators and frankly most experimenters and others, the Nano VNA may be a very frugal alternative. I don't like to use the word cheap because that has other connotations, but certainly frugal, and I'm Scottish. So, from one Scotsman to the frugal technicians and engineers out there, I hope you look forward to another video. By the way, I'm thinking maybe of posting a video I did, frankly, for a local chess club on electronic chess computers. I don't know if that's as appropriate on this channel, but anyway, I made it some months ago and I may post it. But at any rate, until you see that or something else, and as they say, God willing, the creeks don't rise, I will see you again in another video, and in the meantime, have a nice day.